Good morning and good afternoon, everyone. Welcome to the Advanced Urban Air Mobility, Electrification, and eVTOL, a webinar presented by Aerospace Tech Review. Following a challenging year of the pandemic, the transportation industry is undergoing a rapid reinvention, with the aerospace industry leading the way, despite being the hardest hit of the sectors. As governments introduce new measures to get companies to reduce their carbon footprint, regional air mobility will be the next disruptive trend in transportation. The global eVTOL aircraft market, electronic vertical takeoff and landing aircraft market, is expected to reach almost $2 billion by 2035. So what does the future for urban air mobility, or UAM, look like? How about eVTOLs and the required electrification and the infrastructure needed for all of this? The drive from automation to autonomy in aviation is designed to make the industry more efficient and safer. But introducing autonomous systems will require careful considerations of the strengths and the weaknesses of humans and AI. The current lack of infrastructure and regulations, how do we standardize and implement UAM airspace with specific rules, procedures, performance requirements? What are the challenges of making eVTOL affordable to manufacture and to operate? How do we rapidly invest and create the necessary infrastructure for electrification and eVTOLs? What are the certification challenges for autonomous aircraft systems? What are the safety and security aspects of the infrastructure, from the ground operations to CNS, to maximize urban air mobility? In this webinar, we will look at all these questions and more, and how the aerospace sector also needs to adapt to the changing trends in air transportation. And we have great sponsorship opportunities available for companies involved in this exciting sector. So joining me today is a superb panel of 4 experts covering the breadth and depth of our global industry. Each of them will present introductory remarks for about 5 or 10 minutes. Then we'll have a lively Q&A session for the remainder of our 90-minute webinar. I encourage you to submit your questions through this platform, and we'll do our best to address as many as time allows. So let me just quickly provide a rundown of our 4 speakers in the order that they're going to present, and then we'll allow them to present and we'll get going. So our first speaker is, Dominic Cullen. Now, Dominic has been with Eurocontrol for nearly 12 years. He's currently the UAS Implementation Projects Manager for Eurocontrol. He's been in that position for the past year. Prior to Eurocontrol, he's worked for Jaris and Eurocay, and he is basically the point person with regards to the operating UAM whenever it comes online inside of Europe's airspace system. Our second presenter is going to be Terry Olbrechts. He is the Director of Aerospace Industry Solutions, SimCenter Simulation and Test Portfolio at Siemens. He's an electromechanical engineer by degree, and he's been with Siemens or Siemens companies for many, many years. He's been with PLM Software for Siemens for 6 years, nearly 7 years now. Our third speaker is Mr. Greg Bowles. He is the head of government and regulatory affairs for Joby Aviation. He's been in that position for the past 2 years. Prior to that, I knew Greg as a longtime vice president at GAMA, the General Aviation Manufacturers Association. And he joined GAMA way back in 2005 and was responsible for developing new paths for the integration of emerging technologies. Well, now Joby has the privilege of having Greg Bowles on his side. And then finally, we're going to wrap things up with Neil Clowley. Neil is the CEO and founder of Faradair, and it's pioneering advanced air mobility with proven expertise in commercial and unmanned aviation. He's a visionary, he's an entrepreneur, and he's been pioneering a new hybrid electric flight sector since 2014. And he is, again, he's been with Faraday for quite a while. He was their managing director, and now he's their CEO and founder. So with that, I think that we'll have a very lively discussion, very informative, regarding all of the aspects and the challenges with UAM. And so why don't we go ahead and start with Dominique Cullen with Eurocontrol. Dominique, the floor is yours.
Thank you very much, Jeff. So my point would be to give you an overview of the regulatory challenges in the UAM domain. So for a very long time, aviation was really dealing with two main topics for its safety. It was about to be safe to fly first, and then safe to operate. And it was about it. In the last 20 years, we had to include additional features, which were you had to be secure to operate, and now you also have to be green to operate. And these two new items are quite new to aviation, actually, and we are very, very well designed to tackle the first two objectives, and less, I would say, experienced to tackle the two other one. So if I may use this sentence, we try to circle the square, and that's a challenge actually for everyone. So I go over each of the items. Safe to fly. So airworthiness licensing, safety management systems. I mean, they are well-known stuff. I'm not saying that it's done, but actually we have all the knowledge, the skills, the people, the processes to be able to make it work. So it should not be a big deal, actually, to achieve this. There are still some specifics, though, which is electrification of engine. So it's quite something new. There are new processes for these products to put in place, a lot of data to gather to make sure if they are reliable, and all these kind of things. And also, obviously, we have the challenge of automation, which is quite new, although extensively used in the manned aircraft, but still with the pilots there. And when people go up to autonomy, then it's a big void under our feet, and we don't really know how it works, what are the limits, what could be the real challenging and risks. So there is a spectrum of problems in safe to fly, and in the phased approach, I think we should be good to tackle them in a decent number of years. Safe to operate, a bit more challenging. So what do we need? We need an operational concept first. And we all agree that it should be operation-based. So we have something to work on. Concept of operation. So in Europe, we have a concept of operation, which is NEPCORUS, which is not validated, unfortunately. So there is still some question marks there. Then you need a traffic management system. So it's USpace or UTM, whatever you call it, it will be the same. And very lately, we had the USpace regulation 2664, 664, 665, and 666, I would say a few days ago, which were published. And that's a big leap in allowing UAM or even UTM operation. And in addition to that, or to support this, the traffic management system, you have the services. And here is something, it's an open field. We need services to support this new type of aircraft and aviation. And we need to be more specific in the performance, the infrastructure that is supporting it. And we are not that yet, because we are lacking one very specific element, which is a target level of safety expected. And there is still a question mark what it is. Is that VFR, IFR, TLS? We don't really know. Then we have an airspace governance to to address. Is there an evolution to expect compared to what it is today? In some states, it's clear it will not be, and it's in other areas, it's not so clear, I would say. And then you have the CNS services, and obviously, until you don't know which separation you need to manage, it's very difficult to determine the performance of these CNS services. We have a lot of direct services which exist, like GNSS and so on, but are the services actually directing the separation, or do we choose a separation and define the services? That's something which is still to be debated. And a subsidiary question: what kind of UAM are we really aiming at? Is that some point-to-point, like in the left, from an airport to somewhere else, or to very specific platform to another one? Or do we want to have the fifth element type of UAM, in which actually all the traffic is made airborne? That's something which is not still decided. Secure to operate, that's quite a new domain for aviation, also tackled in ICAO for a few years. The problem is that it is highly evolutive, because the technology is evolving so fast that we discover new technologies and new threats and new risks every day. From an operational point of view, it requires a lot of reactivity when you face a security breach. So the governance should take this into account. It also implies a minimum level of trust between the stakeholders, because you need to share some processes, some databases, and if there is not this minimum level of trust, it's very complicated to secure the domain. And also it involves authorities other than aviation, because the communication domain didn't wait for aviation to implement security features. So we need not to negotiate with them. It's not like we lead it. We have to negotiate. And more or less, it's a balance between the industry lead, because it's so evolutive, and the liability, which is we go with it. Can we ask industry to be liable for security, or should we have another way of understanding the whole liability thing? And it depends also on the type of law you're applying. If it's a common law, it's one thing. If it's the other type of law, it's another thing. Now, green to operate. So you have the flux cam, so it's very bad to fly. Sorry for those who love aviation. You also have a new kind of thing, which is privacy, on top of I would say nuisance that we all know. People building up houses near to airfields and then complaining about this. In UAM, it's a bit different, because actually the aircraft is going to where the houses already are. So you bring in a new type of problem. We need to incorporate new technologies, new fuels, maybe new type of energies, which are not really known, as they're known to make the engine work, but they are not known in the long run, I would say, how reliable they are and so on. For sure, it requires external skills and partners, a bit like security, but even wider. And it also involves authorities other than aviation. So here is work in progress. And we need to really put a big effort on that. And for example, Eurocontrol created a brand new unit for green stuff. So that's something very important for Eurocontrol, because the future of aviation maybe lies there more than in technology. I want to also just raise for a couple of seconds another challenge which need to be addressed and understood. Is here at the bottom you have an Airbus study and the evolution of the workforce in Airbus from 2017 to 2030, and when you see that number of people above 50 will actually rise significantly in the next decade, And at the same time, I told you we need new skills, new lot of things. And the younger people actually having those skills will become less and less in the industry. So that's something to tackle as well, how to keep the balance between experience, vision, and stability, and to have new tech skills and more innovative way of thinking. That's something that should be not underestimated. And that's it. Thank you for attention. I think I went into my 10 minutes. I'm ready for questions. Thank you, Jeff. Proceed.
Go through all the presentations first, and then we'll open it up to questions. So second is Mr. Terry Albrechts from Siemens. Terry, please go ahead. Oh, you're muted, Terry.
Oh, am I still muted?
Now you're okay.
Okay, perfect. Thanks, Jeff. Well, first of all, thanks a lot for inviting me and Siemens to this webinar, because we are always very excited to talk about the engineering challenges that our urban air mobility customers, but also the customers who are basically electrifying the propulsion side of aircraft, how, let's say, how they face the engineering challenges and how digitalization can help there. So Siemens, well, within Siemens, we very much believe that a strong digitalization of the complete product development, from defining the requirements over the design, the engineering, the manufacturing, the engineering of the manufacturing environment and assembly, etc., that the deep digitalization will help to really solve a lot of the complex problems in the aircraft development. Because we also strongly believe that, let's say, the new aircraft, whether it's a hybrid electrical aircraft, or urban air mobility systems, will need to be developed in different ways than the aircraft that we have developed in the past. And so what we always say is we try to provide to our customers a way to fly the aircraft before building it, and in that way solving a lot of the problems. So I don't know whether you have felt it, but we actually live in a very pivotal historical moment. As we speak, despite the pandemic situation, there's a lot of urban air mobility, electric aviation projects popping up around the world, and millions of dollars are invested in this complete new market, and completely new business models are being created as we speak. So it actually started 6 to 7 years ago, when some of the companies started to design, build, test, and yes, even flight test electrical propulsion systems for aircraft. And that created a complete new degree of freedom, I would say, to design completely new kind of aircraft configurations, whether it's fixed wing, whether it's vertical takeoff aircraft, or whether it is, let's say, some kind of hybrid type of configuration of the aircraft. Now, the design and the development of and the flight testing of these brand new electrical propulsion units have proven that the power density of the electrical propulsion units can dramatically be increased from, let's say, a typical 1 kilowatt per kilogram electrical motor, which is typically used for train systems or for industrial systems. The industry has been developing motors that reach 10 kilowatt per kilogram, and I believe the industry will also need to work on motors that will have a power density of 15 kilowatt per kilogram. The increase of the power and the energy density also allows to develop new aircraft configurations, and the new aircraft configurations will serve new types of missions, building new kind of business models. And this is where we, as Siemens, we are of course also very proud that we have been at the start of these developments. You know that Siemens eAircraft, which is right now Rolls-Royce Electrical, has been developing very nice motors, whether it's for the fixed wing aircraft, or whether it is for urban air mobility systems like the ones that have been implemented in the Airbus City Airbus. All right, so now we strongly believe that the electrification of the propulsion systems will really be able to disrupt, for instance, here the helicopter market. I believe also the fixed-wing commuter type of aircraft, but I just take the example here of helicopters, because you know that helicopters are very expensive to operate, and this basically comes because of the fact that a helicopter is a very fragile, difficult to maintain, expensive to operate kind of machine, and that has basically been limiting the market growth and the potential of the classical helicopters. Now, with the electrical drives, you have the advantage that, let's say, the propulsion system and the rotor system becomes much more it's much more simpler. The electrical motors are also much more reliable and with reduced complexity and easier to maintain. So I strongly believe that this capability will actually help to disrupt the lower part of the helicopter market, and based on the new capabilities that are present. Having said this, it's also clear that the let's say, companies that are working on electrification of aircraft or on the electrification or the usage of electrical propulsion systems on urban air mobility systems, that there's quite a lot of engineering challenges and also a lot of risks related to the development of these systems. And first of all, we always see a lot of configurations with distributed electrical propulsion, which is very typical, which is very atypical with respect to the aircraft that have been developed up to today. So you have a distributed system, maybe you have a gas turbine that drives a generator, you have an electrical power distribution system that distributes the power to the electrical, let's say, inverters and to the electrical motors. So all these systems will have a lot of interfaces with the aircraft, and that creates a lot of problems. Of course, I already talked about the power density and the energy density, and the problems that are being generated when you take away, let's say, structural mass from an electrical motor. You will also have much more dynamic thermal behavior. You will have thermal management issues and energy management issues. And I believe it also goes without saying that the electrical system, the integration with the electronics, the mechanical side and the software side, that integration problem is also quite atypical. And I just mentioned here the fact that when you look at the vertical takeoff systems, they will have electrical systems that have much more electrical power. And how do you integrate these, let's say, these high voltage systems, high current systems? How do you integrate them? You will have a lot of integration problems with, for instance, just an example, the electromagnetic interference that these systems create. Of course, also automated flight operations. How is the industry going to implement these and make sure that this can happen in a safe way? The acceptance by the community, very important, but also the end-to-end experience for the passengers. So I believe we all have been looking into new business models, but the last, let's say, an operator would like to happen is that such a taxi ride, such an air taxi ride, would get a 1-star Google review because of the fact that it has been a scary ride. We know that the early adopters will typically drive quite expensive cars, very comfortable cars. I believe that these passengers will allow to have a little bit more noise in the cabin, but what we as an industry should certainly avoid is that it's a scary experience, because then the business models will actually collapse. And of course, we see a lot of challenges related to the verification and certification side. I believe that a lot of companies, there's a lot of risk related to the certification. How is this going to happen in a elegant way? I just take some examples of how, let's say, the digital technology can actually help to address quite a lot of the challenges and important challenges that actually are a risk for these aircraft programs, how to actually tackle them from very early on. And I already referred to the flight before you built it motto that we have, but you can also extend that to let's say the manufacturing side. We know that these urban air mobility systems will be produced at much higher rates than a classical helicopter. So the question is, how can you make sure as a company that that you have a manufacturing environment, assembly environment that actually is capable to reach the volumes, and I believe that also their digital technology can help to build the aircraft before manufacturing even the first part. And of course, the integration aspect is there, and the sooner you can integrate the aircraft, the better. And let's say the capabilities that are today available are actually more and more advancing, and give the possibility to look in the certification aspect sooner in the aircraft development. So this is just an example of environmental noise and cabin comfort. So how can you make sure that when an urban air mobility system is injected in some kind of urban environment, how can you make sure that the noise levels on the walkways in between different buildings that reflected the acoustic, let's say, waves. How can you make sure that this is acceptable for the environment? It's not only about reducing the tip speed of the propellers, of course. It's also about the transmission from the source to the receivers on the ground. How is that noise perceived? Is it an annoying noise? Yes or no? Of course, also when you look into hybrid electrical configurations, you will have some kind of gas turbine that drives a generator, some kind of APU or a small APU, which typically creates quite a lot of noise. How are you going to deal with that? But it's also the cabin comfort, of course. How are you going to make sure that the cabin comfort is at least acceptable? Another example of how digitalization can help here, and yes, this is an example of how can you make sure that very soon in the development, you actually make sure that the integration of all the systems, the way how the aircraft will fly through the air, the way how it will need to avoid obstacles that are maybe popping up on the maybe predefined flight path, like the example here on the left-hand side, when you have a construction crane that is being implemented at a certain location. How can you make sure that actually that aircraft is going to fly in the right way, that your control systems connected to the flight control are basically able to avoid the obstacles in time, knowing that, of course, your system, your battery system, your electrical power distribution system, your electrical motors have some kind of limitations. And on the right-hand side, you also see how digitalization helps to model the physical side of the sensors. On the right-hand side, you see the point cloud of a LiDAR system that actually is implemented on the urban air mobility system here. There's actually 3 LiDARs, and you see the effect of the aircraft maneuvers on the visibility of the LiDAR, let's say on what the LiDAR sees. How can you make sure that, for instance, you can avoid flock of birds, that you identify them and avoid them? Yeah. Another aspect is, of course, also the passenger comfort and the passenger safety. It speaks for itself that, of course, you need to develop this kind of aircraft structures, which are typically very light, composite aircraft. You need to be sure that the structure, together with the seat design, actually is capable to absorb energy in more adverse type of landing use cases. But it's not only about, let's say, the heavy landings. It's also about how will the passenger inside the urban air mobility system actually behave. How will he react to certain maneuvers, and how can you avoid that this person becomes sick. Another example, a last example is, as already said, how are you going to make sure that the integrated development of the electrical system together with the wire harness routing inside the aircraft, how can you make sure from very early in the development that keeping into account that you have high power electrical systems, how can you make sure that you have no problems on the EMC type of certification side? So typically we see that a lot of trial and error processes are put in place in the traditional aircraft industry. I believe by coupling all these capabilities together, the electrical CAD, the mechanical CAD, as well as the simulations of the electromagnetic behavior and the thermal behavior of the PCB boards, etc., that this can help to de-risk the electrical system integration. So we at Siemens, we strongly believe that digital twin technology, whether it's digital twin that represents the product or the electrical system or the structural side of the system or the performance, whether it's structural performance, stress systems analysis, that this information is being used also to prepare for the production, make sure that you have actually a well-engineered production environment that goes into a real production where, of course, Siemens, we provide also factory automation systems, which, of course, all on their own create a lot of data, which is, of course, data which is, of course, very important to be reused to bring more insights in your engineering department and make sure that you can improve the product in the next phases. So for that, we have our accelerator portfolio. You can look that up on the internet, of course, where we want to provide to the industry the most complete, comprehensive digital twin, personalized, adapted, and modern, and very open. So that's my presentation, Jeff. Thank you very much for giving me the opportunity. If there are any questions, so let's address them after the presentation.
Yep, absolutely. We'll get to that. A very fascinating presentation. I love those animations. Thank you, Terry. For our third presenter, we're going to go to Greg Bowles, who works for Joby. And Greg, I know that you're heading up their government affairs, and Joby's a big player in this market. It's all you.
Thanks so much, Jeff. And so I think I would say I agree wholeheartedly with the material that Dominique and Thierry just kind of laid out. So this is a complex endeavor for sure. At Joby, we've been working on this a long time. So the company's been working on these challenges for over 10 years at this point. And I'll give you a quick overview of the product and the segment that we're working in, and kind of excited to talk through some of the questions coming in on the certification challenges in the second half. So the Joby aircraft is an all-electric airplane. It has one pilot, so we're a piloted airplane that also has 4 passenger seats. Each passenger has their own door to expedite boarding and deboarding of the aircraft. The aircraft, so I said an airplane, right? So an airplane traditionally would do a rolling conventional takeoff. Our aircraft can also do vertical takeoff and landing. So that's a unique aspect that electric lets us bring to the table. Being electric, the aircraft has 0 emissions when it's operating. One of the challenges that's often highlighted with electric is the power density and the energy density of battery technology. The good news is today's industrialized battery technologies and chemistries, we're using those, and we're able to fly this aircraft over 150 miles with a 30-minute energy reserve on board. And that's more than sufficient for the use cases that we were looking at. In fact, our median uses are going to be somewhere around the 20 to 50 mile range. And so energy density is in a wonderful place. We've all watched that develop over the last 20 years, and certainly will continue to get better, but it's in a wonderful place today. The aircraft that we've developed flies 175 knots true, about 200 miles an hour. And I had mentioned we've been developing this for quite a while. So from a regulatory perspective and from kind of the numbers, I think one thing that's important is to kind of compare this against traditional aviation. So I put a Cirrus airplane up on the board there, and you can kind of see how we stack up against that. So this airplane is an FA Part 23 normal category airplane being certified under the new regulatory construct that has the additional flexibility to be leveraging a lot of the industry standards around the world. I mentioned one pilot, 4 passengers. The airplane weighs 4,800 pounds at max gross takeoff weight. The ceiling of the aircraft is 15,000 feet. On typical missions, we'll fly at GA type altitudes, the general aviation type altitudes of 1,500 to 2,000 foot above the ground. The aircraft will initially be certified as day-night VFR, and we'll certainly be adding IFR capability shortly thereafter, and non-flight to non-icing. So initially, energy densities, using those for the removal of ice is difficult. So what's non-traditional about this aircraft? Well, it's all electric, so that's non-traditional, and I think that was highlighted by our friends at Siemens. We've put a lot of time, and a very serious team has been employed to develop our motors, our batteries, our high power electronics that go into the design here. And part of the key is not just focusing on those technologies individually, but it's efficiently integrating those technologies. So the challenges of cooling, the challenges of parasitic drag, the challenges of having the right energy and power densities, they really do present some amazing opportunities if you go down a well-developed, organized path. Sometimes pulling off the shelf technologies, it can be difficult to hit exactly the point designs you need. And then, of course, this aircraft is also capable of doing vertical takeoff and landing. So from a time perspective, we've actually been flying these aircraft.
I think we may have lost you, Greg. So I think we may have lost you. I'll ask Terry. Terry, can you see if is Greg still talking? Oh, you're muted.
So I see everyone. Well, I can hear you, Jeff.
Okay.
And I can see everyone moving, but Greg's picture is
Frozen.
Yeah, frozen. Okay. Yes.
All right. Well, we will allow him to get his presentation back up and running. But until that time, let's ask a few questions. And while we're waiting, I see Greg has disappeared, and he'll probably be coming back online. Let me ask you a question, Terry. The content you showed is mainly about simulation. What's your view on using simulation as proof of compliance for certification?
Mm-hmm. Well, do you hear me, Jeff?
Yes, I hear you.
Great. Okay. So that's a very good question. And we, that a lot of computer capabilities, a lot of simulation capabilities become, let's say, become more and more advanced and can deal with much more physical simulation, with simulating the physics, whether it's CFD, whether it's structural side, whether it's system side. But of course, you will always need to prove to the airworthiness authorities that, let's say, the approach that you have taken, that the parameterization that you have used in the simulation, that these are right. So certification goes never without testing. And that's exactly where we at Siemens also provide the solutions to actually make that handshake happen between simulation and testing to let's say help customers implementing the right processes. It's not only about, let's say, the simulation side. As long as there will be innovation in this industry, as long as the industry will use new kind of materials like additive manufactured structures, or as long as there will be new, let's say, system architectures like electrical propulsion units, that long the industry will need to prove that the assumptions that are taken in the simulations are right, and that kind of evidence comes with testing. So we at Siemens, we strongly believe that the data that is being created in the simulation can help to de-risk the creation of data for the proof of compliance. In certain cases, for instance, for specific very dangerous cases which you would not like to test, you can use simulation, but of course a lot of testing will need to happen. And the question there is, how do you keep that data that you create from virtual testing or from physical testing? How can you keep that together? How can you keep that in context of the type certificate? How can you keep that in context of the requirements within this and, let's say, the next 30 years that your aircraft will fly is, of course, very important. So we know at Siemens that it's not all about virtual. At a certain moment, the product is touching reality, is becoming reality. And in that sense, yes, we do have solutions there.
Okay, and we had another similar question come through on the webinar here, asking if, and you're kind of answering it, and the answer is it's a work in progress. But it says, do you see digitization and simulation as a future means of vetting airworthiness, or even taking airworthiness certification credit for aspects of these systems? I think that your answer would be yes. And it asks what characteristics must be satisfied in order to take certification credit from simulations.
I believe that everyone who wants to set up a certified development will need to provide the evidence that the assumptions are right. So certainly new companies will have to do a lot of testing. And of course, the question is then, how can you make sure that all these tests are very well documented, such that the next time, the next program, you can actually benefit from that investment and reuse then reuse that information and the assumptions that you have been using. So yes, there will be a lot in the future. There will be a lot of let's say a proof of compliance based on a simulation, but it will never go without that experience, that physical testing experience, and in certain cases, as already said, in difficult let's say in cases where the physical testing would be very dangerous to do, simulation can help already today.
Okay, and that's a great segue to get back into what Greg Bowles was discussing. Greg, I guess the Wi-Fi let all of us down, but it's good to have you back. And why don't you go ahead and pick up exactly where you left off, because we were just talking about certification.
Awesome. Yeah, I apologize for that. I think we're back in live, so that's wonderful. So Joby is also planning to be the commercial operator. So we'll be standing up in the U.S. the Part 135 commercial operation, and around the world, of course, under EASA Ops 1 and other key operational commercial activities. So the point is that these activities fit into the existing regulatory context, but they provide a really interesting opportunity for us to evolve going forward. So this aircraft, for example, has been designed to fly in traditional airspace. So I've said someday for Class A, because we intend to operate our aircraft below 15,000 feet, Class A being 18,000. But traditional airspace operations are a wonderful opportunity in the early days. In the U.S. system, one of the things that happened in 1946, the Federal Airport Act laid out 5,080 airports. Actually, back then it was even more. We now have 5,080 left in the U.S., and that's an amazing opportunity. Actually, I just saw a NASA study in the U.S. that came out and said that everyone lives within 16 minutes of an airport in the U.S., which is an amazing opportunity. So thinking about this, and we're coming out of this period of COVID, we're coming into a world where electric aviation is anew. It provides the world amazing opportunities to think about this. The economies that took strong use of aviation over the last 100 years have really been dominant. And going into the next century, economies that understand how to invest in this space, this electric aircraft space, how to build the infrastructure and take advantage of what these new designs can do, this will assure the future economies. And that's why this is so important to everybody. So what exactly is that future infrastructure? We generally look at runways and heliports as opportunities for today's operations. And going forward, vertiports or skyports, depending on how you like to moniker them. They essentially are very similar to opportunities as heliports would provide, except they have stricter noise standards potentially, and would have electric charging, but a very similar piece of pavement. So that's the presentation I wanted to bring. Absolutely looking forward to the conversation about the true certification path. As I kind of jump off the live stage here into the question period, and my colleague Neil will kind of jump in next. I think it will be important to kind of talk through how the existing system can be leveraged to certify today's products that are at the door, and then the evolving products that will continue to come through.
Great, thanks, Greg. That is an excellent transition to our fourth and final presenter, and that's Neil Clohey of Ferrodair. Go ahead, Neil.
Thanks, Jeff. Good afternoon, everyone. Tail gun Charlie here on this one, so I'll just wait for the slides to come up and then I'll take over. But basically, what you've heard so far is an awful lot of the ecosphere, if you like, for urban air mobility. And as part of that, it really started off talking about a lot of eVTOLs and intercity transport. And we've been talking about the sector more from the regional perspective since about 2014. And as you can see, we're far more of a fixed wing platform and a hybrid electric initially. And I'll come into some details about what we've done in the last 5-6 years, where we're at now, and where we see the future going in terms of the sector, and some of the more interesting announcements that have been happening just recently. First thing I just want to touch on, though, is the world definitely changed for aerospace last year. And personally, my belief is that we will look back in 20 years' time, that 2020 may have in fact been an extremely pivotal year for the world of aerospace. The global pandemic that we've been facing and currently still facing is going to put a mark on us for a very long time. But it also gave us just a snapshot view of what is possible. We had come to live for decades with cloudy, smog-filled skies, with busy roads and everything else. And when all of that stops and the air clears and there's no aircraft flying, there's no cars on the road, suddenly everybody looks at that environment they've never seen for decades and go, actually, you know what, I really quite like this. So what we have seen in the last 12 months, certainly, even though many of us have been working on this for many years now, we've seen a real focus and a real agenda, not only by governments, but by regulatory bodies and also investors and people wanting to come into this market, realizing that sustainability doesn't just happen with electric vehicles on the road, but also now can apply to aerospace as well. So whilst one inside of our business has been taking an absolute beating of that, there's no doubt, and I think probably hit some of the hardest in the world, it has given these green shoots of opportunity and growth for the electric and the hybrid electric side of things. So, as I say, we were launched in 2014. I had this wild and crazy idea, having spent many years in the commercial aircraft market, to look at the regional flight mobility opportunity. And that was really because of the technologies coming forward, both in materials, carbon composite technologies, but also really specifically the electric motors technology. If anybody had said 10 years ago or even 15 years ago that a four-door sedan was going to out-accelerate a Lamborghini, you'd probably be told you were mad. Now, I had the great privilege and benefit of actually having a drive in a little coupe electric car in 2008 in Burlingame in California, which was the certain Tesla Roadster prototype car, which I do believe is the car that has now been fired into space. But we've seen an evolution in electric transport in just a very short space of time. And we're starting to now see that in aerospace. But as discussed here, we are seeing some challenges in terms of power density, et cetera, for some of the longer range missions, heavier payloads, et cetera. The shorter range, we already have a certified electric aircraft. Pipistrel have got the little two-seat airplane certified, which is fantastic. We're seeing the superb developments by Joby and their aircraft getting up and flying, which I think is certainly by far and away, in my opinion, one of the leading candidates in the eVTOL market right now. And then, but we want to look at the wider picture as well. So what we believe is that there is an opportunity to link cities, as just been perfectly shown by that map shown by Greg there, that there are airfields and infrastructures already in existence in countries throughout the world. And whilst we are going to be working on new technologies, new chemical compositions of batteries, hydrogen, fuel cells, things like that, there are a lot of technologies competing right now to be the net zero choice for the future for long range and heavier payload. What we saw was an opportunity to do hybrid. Now, I'll walk you through just a little bit now of why we think that this is the right path for us right now. Before I do that, one of the key things that has driven me behind this project personally was I lived in the States and California 4 years, and I came back here in 2009. And for me, the fact that the UK no longer had a whole aircraft manufacturing market was really a great shame. If you look back throughout the history, if you look at France, the US, and the UK, really the major pioneer centers for aerospace and innovation. And in the UK, some of these aircraft that you're seeing on that screen there now are all British commercial aircraft that used to exist, sadly no longer. So I thought, right, let's change that. Let's see if we can now use some of these technologies and integrate them into a new asset that will enable us to do a new regional flight model that maybe can do things that existing assets can't. So in June of 2020, in the midst of the pandemic, we were approached by the Imperial War Museum and Gonville & Caius College, a college with over 600 years history and some 15 Nobel Prize winners to its name. They own, for 400 years, they've owned the land all around this extremely iconic airfield, which was one of the key airfields of the Battle of Britain. It is a fantastic living monument to what that period was, and even with aircraft flying to this day from that period. But what we want to do now is to marry the heritage and the history of the past with the future. And so really the honor is ours to be invited to become part of this story here and set up our base here. And so on the 1st of September, we relocated the business, and we are in our temporary offices. The new executive offices are being renovated, and we'll have a new prototyping hangar here, hopefully within the next 18 months. A lot of our engineering work is going to be going on in Swansea in Wales. But really, for us, back to one of the points earlier discussed about the shortage of skills, the lack of people coming into the market, it is places like this where we can get people inspired by what we've done in the past, but really get them motivated to see what's going on in the future. So combining historic aircraft flights with clean energy, sustainable aircraft flights where people can actually see what it is that they're going to be getting into in the next 5, 10, 15 years into the future is a really important exercise for us. So from our perspective, it is a net zero airplane. The BHA is a hybrid electric aircraft, but we'll be using sustainable aviation fuel combined with the electric motors. And we do believe there's going to be an opportunity in the future for us to go fully net zero by either hydrogen fuel cell or electric pack in the future. So I'm going to rattle through these a little quicker now. Part of this process is all about partnerships and growth. So once we've moved in, some of the key components for our aircraft needed to be secured. So things like the turbo generator. So we had always planned to use a turboprop with an electric motor, i.e. use the turboprop at half power, supplemented by the electric motor, and that would give us a fuel burn saving on sustainable aviation fuel. But the key was if we could get a serial hybrid system, could we get a turbo generator that could give us enough power to actually power the electric motors? And so Honeywell have created this fantastic new turbo generator, 280 pounds in weight and some 1 megawatt in power. Is a superb piece of kit. Combined now with the Magnex motors that we'll have on the back of the aircraft. Again, Magnex flying a huge number of flights at the moment, and those motors will be type certified when we're ready to start flying our airplane. And we have a whole range of other partners, including the likes of Cambridge Consultants, Nova Systems, involved in the whole structural engineering of the program, of course, IWM, Gonville & Caius, Swansea University, ProDrive, VWV, and the list is growing. So it's a very, very exciting time for us. In terms of the aircraft itself, many of you probably have seen it or heard of it or heard about this triple box wing regional air mobility aircraft. So how do we look at this? We wanted to certify an aircraft that could operate in extremely confined environments, a true utility workhorse, which means that we could not be range constrained. We could not have to have a whole new infrastructure put into airfields. We had to be able to operate in airfields throughout the world with their existing infrastructure. So we decided that this serial turbo generator gave us the opportunity to power those electric motors at the back of the aircraft with an extremely high lift design of airplane. It isn't just designed for the civilian market. It is also designed for a range of multi-role capabilities, both in non-civilian, cargo, and other missions, which I'll talk about in just a second. But really, it's about using some of these technologies in a design that actually has got a 30-year history and legacy. The box wing configuration was proven and pulled together for a US Navy military requirement for UAVs back in the mid-80s. So there is a long pedigree behind this asset, and it's quite an exciting piece of kit, which we look forward to demonstrating. So what is it that we're talking about in terms of utility? We basically see an environment where You have to be able to use the asset for many hours of the day, and you've got to be able to use it for many things. So that means that what you've got is what is more commonly known in the commercial aircraft market as a combi. The ability to convert from passenger to cargo operations was always going to be a driving factor. So we call it an 18-seat airplane, even though we're in the 19-seat commuter category for Part 23. It is a 6, 6, and 6-seat configuration, which can unclip, unplug, come out, and be replaced by 3 LD3 containers. As I said, the electric motors at the back of the aircraft are powered by a turbo generator running sustainable aviation fuel, or if need be, we could run Jet A. Now, as I say, the idea behind having this configuration enables us to swap that power pack for something different in the future. And we believe that the aircraft will be full net zero, certainly before 2030 in certain missions and capabilities. Now, if you look at how the market has changed and evolved, we've got UBS now talking about hybrid electric aircraft market to be worth 178 billion. We're seeing investors, we're seeing people now really starting to cotton on to the idea of sustainable air mobility. The ability to do it on a short range basis through aircraft, more like the Joby aircraft from around cities, around the urban environment and out to the neighboring suburbs. And then we're looking at much longer range capabilities where, again, RPKs are king, revenue passenger kilometers, getting lots of passengers on board, but an aircraft that is quiet, an aircraft that is not going to upset the locals, which means that certain architectures and designs just simply won't be possible. For example, you cannot fly into London City after 10:30 at night currently because of noise regulations. So we very much focus on the fact that we're looking to build an aircraft that by field perimeter will have about a 60 decibel noise footprint. And so to the point that Thierry was making about what you do with the noise of an APU, a turbo generator, we have got this piping into our acoustic reduction duct, which not only absorbs a lot of the sound from that exhaust port, but it is also a perfect de-icing solution for that prop fan on the back of the aircraft. Likewise, battery configuration. So we will have batteries for taxiing on the ground, about 15 minutes worth of reserve flight time, but really it's the turbo generator which powers those electric motors for the main flight. Should that stop, we have the backup reserve of those batteries, and everything that we do on the ground will be fully electric powered through our electrified landing gear. In terms of other opportunities, again, having lived in California, I know what the threat of wildfire is like, and I've also worked with and spoken with the guys who did the initial fire tanker conversions of commercial aircraft. Wildfires grow massively at nighttime currently. Of course, aircraft can't fly at night. So we're very much looking at a whole range of unmanned logistical capabilities for the aircraft. And it seemed logical then that if we've got a containerized solution for the aircraft for cargo, then why shouldn't we put that into a retardant situation where we can carry more payload than helicopters, base aircraft near the fires, and then also be able to attack them at night with a whole range of flight systems, including autonomous flight capability. That is something that we are already working on, and we hope to be able to demonstrate. Obviously, for civilian use over the urban environment, that will be a considerable way further away. But for certainly military and firefighting applications, we see autonomous flight with some really interesting growth opportunity. And so 5 tons of payload, taking off and landing in less than 300 meters of runway. We think that that's quite an exciting period and thing to be in. So with our growing list of partners, we are looking to transform regional air mobility as part of the whole advanced air mobility market. We see ourselves at the longer range end and the bigger payloads. But really what we're building is a workhorse. It's a standard airplane. It's a Part 23 airplane, has some new technologies involved like the hybrid propulsion, but really it's an awful lot of standard capability. And so therefore it has no infrastructure requirements in terms of airfields. So long as they've got either sustainable aviation fuel or Jet A, we can operate there. And we are very much looking forward to demonstrating routes and capabilities. So as part of that, we have announced our intention to build a 300 aircraft portfolio, the first portfolio, by 2030. That's about a 60 aircraft per year production rate. And as part of that, we'll have about 150 in firefighter freighter configuration, 75 in regional air mobility of people, 50 pure designated freighters, and then 25 in special mission capability for governments and regional organizations. So that's where we're going to deploy these assets. We believe that firefighting and actually doing something of direct impact to the ecological environment is hugely important in addition to building a sustainable aircraft. So that's what we're about. And we're very much honored to be part of this panel. It's been a pleasure to talk to you and be happy to take any questions that you may have. Thanks ever so much.
Thank you, Neil. Excellent presentation. So I think I failed to introduce myself and why I'm here. Well, I think I said my name is Jeff Gazzetti, but one of the reasons I'm here is because I wrote an article in Aerospace Tech Review, the latest edition, called the ABCs of UAM infrastructure. And if you don't build it, they won't come. And so I just wanted to start out with that. I've been in the aviation industry for the FAA and the NTSB, mostly with safety and investigations, and also as an aerospace engineer. But I'll go to Neil first on this. This is a question that came in with regards to the infrastructure. The ABCs, by the way, A being aerodromes, B being the byways in the sky, and C being collaboration and community. But Neil, a question came in. It says, what does Faraday believe are going to be the prime geographical markets for regional air mobility, and why?
Interesting one. I mean, from our perspective, we can use some tangible examples right here, right now. So, for example, if you want to go from, I'll use the UK, but you could equally use California, Sacramento to San Francisco, those types of routes. But let's say Cheltenham to London. At the moment, if you want to do a season ticket on the rail, that's going to cost you £10,000 per year for a season ticket for a journey which is about an hour and 3/4. If you want to turn up to the ticket booth right on the peak time there and then and buy a ticket, it's best part of over £200 for the ticket. How on earth are we in that position in 2021? The rail track has been there for years. This rolling stock has been there for years. And yet every year the price goes up by 3 to 4%. So we believe that that is an opportunity that is ripe for change. Now, equally, when you start a regional airline and you're operating and then you complain that you go bust because of Brexit, when you're trying to operate an ERJ 145 regional jet out of Heathrow with an average of 18 passengers on board, that might have more to do with why you'll go bust. Whereas if you've taken those same 18 passengers, put them in this thing behind me and gone 5 miles to the north of Heathrow at Northolt and flown between London and Manchester in 45 minutes for a £25 each way fare, I know that we'll fill every single seat on that airplane, and you've got a basic economic business model that makes sense. So if you look around the countryside of any country, you will see not only general aviation airfields, but you'll see airfields that are crying out for opportunities to serve members of the public for affordable flight without being converted into housing. And much of our airfields are being threatened at the moment with brownfield development and losing much of our aerospace capability through the requirement for housing. So we believe that the ability for people to use their local regional airfields in what we call a 15 minutes curbside to airside experience, where people can arrive, pull up, check in through the security gate, and the aircraft is going to be leaving much like a bus would from a Greyhound terminal or National Express, etc. It leaves. If you're on it, you're on it. If not, you have to wait for the next one in an hour or so's time. And so linking some of these pairs and cities that have never had commercial air service is only possible if you've got an economic business model that can support that. And more importantly, you've got an asset that half the population aren't going to get upset at you about for operating it near their back door, which is always the threat.
Okay, great. Thank you. With regard for Dominic, here's a question that came in with respect to your point, Dominic, on manpower demographic challenges. Will the current trend discussed by recent studies that show a significant percentage of the current workforce move from their existing employment, they're going to have to look for new work. Do you see this as a possible positive situation for UAM with regards to manpower?
That's when you look at human resources, it's always a matter of skills. And opportunity, and the market supporting the need for new workforce. I mean, of course, it will attract a lot of people. Now, will these people have the adequate skills? That's another story. When I listen to Greg and Neil, of course, you have all the ancillary services which are behind the service, because you see the Neil, you see that as a service more or less. That can attract a lot of people, obviously. But when you look at the technology or the intelligence which are behind these machines, only people who are in the aerospace industry for quite a long time could actually work into this business. So we have to make a difference between the building the service and actually serving the service. So that's where I think there is more opportunity in the service itself than in the in industry. If it's clear what I said.
It is. And also you indicated, Dominic, that you wrote or were a major player in the concept of operations, the ConOps in Europe. Of course, in the United States, the FAA has been publishing ConOps. I think they're, they put out a second version a few months ago. Have you been tracking what the FAA has done with regards to how air traffic in the United States is going to deal with UAM and compared that with how Europe will deal with it?
In Europe, in general, we have a different view. I mean, I'd say when I say Europe, it's European Union. I'm sorry for British participants, but it might be a slight difference. I mean, the US are more not conservative in the way that it's bad, but they are more pragmatic and building up at what exists and what works. In Europe, the concept is more, I would say, advanced and conceptual, which means that there are some risks taken. In the US, I believe it's more reasonable to move from what already exists, and that may be because the general aviation is much more alive in the US than it is in Europe in general. I don't have the number of exact number of general aviation aircraft in the US, but compared to Europe, which is significant though, it's another order of magnitude.
Understood.
So I guess the not the lobby, but the force which is behind general aviation in the US played a significant role in the evolution of the concept of operation in the US compared to the one in Europe.
Okay, and that brings up a good point, with regards to how these eVTOLs and the electrification of aircraft, their application is going to have to be different in different parts of the world. For example, China, their regulations may not be as robust. They may have different unique characteristics. It's going to differ than Europe and
and so on.
Right. Greg Bowles, like to go to you. To your point on using existing airports, many may not have the electrical capability to charge these vehicles. What are your thoughts on how to improve that part of the infrastructure with regards to having charging stations at these vertiports that Joby's going to be hopefully operating in and out of?
Yeah, absolutely. So, what's interesting about the electrification piece is generally aircraft levels that we're seeing across the industry, they're well less than a megawatt to charge. If you look at, for example, a Tesla, so wherever you see a Tesla supercharger, there's typically 1 or 2, 3 of those Tesla superchargers in a bank. 3 of those is a megawatt of power grid demand. And so you can imagine that I haven't actually been to one that had less than 3 chargers. If you look at the number of electric cars today, there's about 20 million electric cars in the world, and the projections are over 100 million by the end of the decade. So what's happening on the surface is a huge amount of electrification. That's what's going on the surface. So the generation, the running of the copper, the building out the infrastructure for the surface, that's humongous. Let's look at the airplane side for a second. So if we're all wildly successful, which we think we will be, and I think the reason this subject resonates with so many people is because we all want this. There's a huge societal demand. We know the technologies are here, and the execution it's time to execute. And so with amazing execution, let's imagine we have 2,000 or 3,000 of these aircraft in existence by the 2030 time period. and they're pulling in, well less than a megawatt, say half that, in charging. It doesn't scratch the surface compared to what's happening with electrification on the ground. Now that does mean we need to spend time running copper and putting the infrastructure into airports, revitalizing them. Some of the good news is in the U.S. there's a bill that's just been introduced and is being circulated around that would try to focus on some of that. Some of the infrastructure focus includes aviation. I think around the world we'll see a lot of infrastructure spending, and I think it's really important that infrastructure spending, when we look at electrification at large, it includes aviation. So it'd be very short-sighted to miss the fact that the next decade's about the electrification of aviation. And so we're very, very fortunate, to be frank, to have this technology, societal demand happening at a time where these kind of changes are growing out. The 2020s are going to be amazing for the electrification of aircraft.
And staying with you on that with regards to batteries and electrification, can you describe Joby's safety approach to its battery pack regarding independence and isolation?
Yeah, absolutely. So it went generally without saying, safety is absolutely the number one priority for Joby. It's the number one priority for all the serious actors in this space. Everybody has had really serious conversations together about that. So taking a dive, what does that mean for battery safety? So we're all aware of the early experiences we had with lithium-ion batteries. Out of that, standards like RTCA DO311A developed. So we're utilizing that standard for the core of the battery. So we begin with the foundation of making sure that the chemistry is an extremely safe chemistry. We do a lot of things to monitor the short-term and long-term evolution of every battery. So we know every cell, what's happening over the long term of that cell. We package those cells together in a way so that there can't be a thermal event between cells, so that if with all that work done, the unknown happened and a cell went into the thermal event, it doesn't spread to other cells in the pack. And then we even assume that would fail and the entire pack would go into a thermal event, and that's a safe event for the aircraft. So this layered kind of approach is what's required by standards like DO311A, and I think it's a necessary level of testing. Beyond that, we obviously have redundancy in the packs. So I don't know if we've disclosed publicly the number of packs on board, but we do have redundancy in the battery packs on the aircraft as well. Each of our motors is supplied by independent batteries and has dual sets of windings to be dual redundant. So on our product, you saw 6 propellers. They're actually being turned by each dual redundant.
Okay, and for Terry Olbrechts at Siemens, have you given thought about the safety of these the high density electric batteries, and can simulations help with that?
Well, absolutely. Yeah. So there's different ways to actually model the different batteries and the configurations, the electrical configurations, but also the configuration of the different battery cells inside a battery pack and connected to the cooling system that is there. So the capabilities are there to go quite deep into the physics of the batteries, whether it's the chemical physics, whether it's the electrochemical physics, the thermal physics, the interaction with the cooling system, the interaction with, let's say, the structure around the batteries, and then to the next level, how that battery actually operates within a integrated system. So yes, the digital tools allow to basically model these different configurations and look into what are the best performing ones, also keeping into account aging of batteries, and looking into also the safety side of it, reliability, create some model-based risk digital twins, I would say, that give the engineering community insight in what are the best decisions for that aircraft and that mission.
Okay. And to Neil, what certification standards should we expect? This is a question that just came in. What certification standard should we expect for electric engines? Will they be certified under CS-E or some other evolving standard? What are your thoughts on that?
Very much a moving target right now. And I think what was interesting is we just had the hybrid electric architecture just issued by EASA just in this past week or so. And I think that really one of the key questions that we're now going to have to ask ourselves as an industry is, do we still have the regional authorities going off doing their own thing? Or do we really now need to start getting the regulators to start singing on the same hymn sheet? So EASA, FAA, CAA, the Chinese, the Australians, the Canadians, can we now sort of start getting these regulators to realize that there just is no point in everybody going off down their slightly different path? And I think that one of the greatest opportunities this year, and certainly next year, would be for the regulators to be doing a lot more roundtables between each other to make sure that we get a definitive path that we can all sign up to on the electric motor. So for example, I defer an awful lot of that capability to our partners at Magnex. They're all over this. They're working very closely with the FAA in terms of what's possible, in terms of cycle use, in terms of maintenance, and how many, what the TBO hours are going to be on these things. So really all of this is already ongoing. But I think the importance is to make sure that we do try and get a common driven standard. Because if we don't, to the point you made earlier about whatever may be possible in China may not be acceptable in the West, it really does benefit the whole industry if we do start getting that common standard. And really that needs to happen sooner rather than later if we're all to meet our business goals and objectives within the next 5 to 10 years.
I agree. There's no doubt about that. There seems to be a lot of consensus around that. The rub is, how do you do that effectively and efficiently? And I think the industry will find a way to do that. Sticking with you, Neil, we're hearing a lot about hydrogen-powered commercial aircraft. Is this technology limited to that segment of the industry, or might we see this arrive first with urban air mobility?
Well, it's interesting, and I saw some of the other commentaries coming about icing conditions and various other bits and pieces as well. And I think, yeah, I mean, if you look at testing and evaluating aircraft, you can do that very effectively on small aircraft, and you can prove a concept. But let's look at the problem that we're trying to solve. The problem that we're trying to solve, and as highlighted by the French recent ban on short air travel, is that there is a perception that we are flying jets for short trips that we really shouldn't be doing. Could that be replaced by hydrogen? Potentially, yes, it could. Hydrogen fuel cells and hydrogen fuel systems are certainly an interesting opportunity. But then, of course, we've got to look at the whole reason as to why we're doing it. If it is green, then obviously we know that green hydrogen is prohibitively expensive to use for mass transport, which means that what we're going to be doing is what is now labeled as blue hydrogen, which just a few years ago was known as brown hydrogen. And there really does have to be a very sensible debate, and a lot of very highly qualified engineers are looking at the energy burning process and the entire process of creating that hydrogen fuel. You have to look at the true environmental footprint of that versus potentially even just burning a sustainable aviation fuel in a jet turbine. I mean, how much better is it? We don't yet know. That also comes with an infrastructure requirement. So if we are trying to reach what we are talking about, as Greg quite rightly highlighted, a whole bunch of airfields that do not have commercial air service transport today, are any of these airfields honestly going to be investing a huge amount of money in putting in new infrastructure here and now? Probably not. Electrical infrastructure is certainly easier potentially than the hydrogen infrastructure, but anything that requires a lot of infrastructure investment is going to be deeply unattractive to some of these more remote airfields. So certainly from our perspective, being able to operate to airfields in Africa, in India, in China, in Europe, in South America, where they may not have those infrastructures, then that is starting this regional mobility movement, getting people used to using air transport like they would a bus. And to the point that was asked specifically, do I think that the ban in France is going to hinder UAM? Absolutely not, because that is very much targeted at your A320s and your bigger airplanes. General aviation can still fly, business aviation can still fly, and I do believe that the authorities will recognize that anything that is sustainable, i.e. hybrid electric or all electric, be it UAM, eVTOLs, etc., that can only be a benefit to people. So those will very clearly be singled out as aircraft that can continue to operate. What they're really looking to do is they're trying to stop the big passenger jets from doing these short haul trips. So I don't think there's going to be, if anything, I think it's actually going to boost the UAM and the regional air mobility market.
Okay, thanks. We got about 10 minutes left, so let me ask a couple of other questions that are coming in on the webinar, and this one's for Dominic. Do you imagine, Dominic, these UAMs flying like within skyscrapers in Brussels or Paris, at that level, in that urban environment where you're a passenger and you're looking up and you're seeing a skyscraper? Do you really envision that happening? And if so, what's going to be required? How close are we to that?
So I recently discussed with some people in the DG Move from the European Commission, and actually they are urban air mobility will be a part of intermodality greater transportation scheme. So there are operations in which aviation is very efficient, and for some it's very inefficient because it takes a lot of energy to fly. By definition, it's simple physics. So you must use this for highly valuable transportation needs. It could be persons, obviously, or it could be long haul because you avoid some choke points and stuff like that, where actually you lose energy just because at some point you get congested, just like what Neil was saying. So it actually every type of transportation will have its place, but we need, I would say, to put everything on the table, and for any type of good and people, and why do we move? What moves? Which distance? For which purpose? And actually really look at all of this to find the best balance. And I don't see UAM massively flying over cities.
Okay.
Because it will always be dangerous, and also there will be this feeling of being. I don't know, but Neil was saying something very true at the beginning. I mean, last year it was something brand new for a lot of people. We're old enough to have seen landscapes and nice, clear skies and so on. But some youngsters, all their lives they lived in smog, and for them it was a shock. And I'm not sure they want to go back to year 2019. So they will urge for having something cleaner. I'm not saying greener, but cleaner. And that's where actually we need to, with our experience, to put everything we know to offer that to the new generation.
Well, that's interesting, and that's one of the takeaways I've taken from this panel is all of you seem to be saying that the whole cleaner, greener aspect of this is really a main driver of this industry. It's not just the high density batteries and the electric motors. It's the fact that it's a whole new industry that's going to be a lot greener than the current industry. And I think I certainly have noticed the skies getting clearer because of what's happened because of COVID. But do you all really believe that it's the citizens' push for greener technology and the need for that is going to be a primary driver of this industry? I guess I'll ask Greg that first.
So I think there's no question that the consciousness for the planet and the environment is going to grow. I can look at my own son being raised and what he's being taught compared to what we were all taught as young children, and so there's no question that planetary consciousness will grow, and so I think the efforts underway by the existing industry and the airlines to go towards sustainable fuels, the discussions about using hydrogen, discussions about moving to all electric. The truth of the matter is that energy densities and the complexity of these solutions are such that the electrification of aviation begins where we're talking, right? 10 years ago, it began with companies like Pipistrel, with little 2-seat gliders and trainers. Energy densities and power densities are such that now we can do we're doing what we're showing you now. 10 years from now, efforts will continue to grow. I think there's no question on that.
Okay, and Neil, I know that well, actually, I know what you think. You're very strong. You're the one that presented those PowerPoint slides with the before and after. But Terry, do you agree that there's an incentive by industry to build around green technologies for aviation?
Absolutely, and that's what I meant with the pivotal moment 6 to 7 years ago, when you saw all these initiatives related to electric aviation, and as Greg already explained, going from the small general aviation aircraft growing into, let's say, electrical motors that are capable to deliver 2 megawatts of power, that are able to drive the let's say, that are able to propel the let's say, commuter type of aircraft. I believe we see these evolutions happen, and I believe there's no way back to let's say, the traditional aircraft. And it's also quite interesting, by the way, when you look at the aircraft configurations that we fly until today, like the 737, like the A320, they all have been based on the configuration of the prototype, the -80, the 707 prototype,
Right.
that has been flying since, I believe, 54 or something. And I'm really happy that I see new aircraft configurations like Joby's one, like Neil's one, and I hope to make some business trips in those within, let's say, the 15 years that I still have a professional life, and hopefully afterwards as well. So yes, I believe there's no way back, and looking forward to these new aircraft configurations.
So great. Now here's a lightning round, just a short answer from the four of you. Then we have to close out because we're 3 minutes away from getting shut down. How many years out is it going to be before we see a flying certified eVTOL or electrified aircraft that's legal, passengers are on it, and it's operational? How many years away are we from that? Neil?
Oh, you caught me there. I was thinking you're going to go Greg first. Well, we've basically said we're targeting our aircraft to be flying by the end of 2024. And if the Part 23 regs are simplified and work to the way that everybody's discussing, we're hoping the certification program will be a 2-year period thereafter. So by the end of 2026, we hope to be flying our first commercial hybrid electric flight from here at Duxford in the end of 2026. And then, of course, the full net zero version probably by sometime around 2030. That's our forecast.
Wow.
That's my bid.
Terry, what's your prediction?
6.5 years. No, I'm joking. So between 5 and 10 years, I believe the industry will have an aircraft that is mature enough to operate in commercial conditions.
Oh, okay. Greg Bowles.
So we are on good track to certify the airplane at the end of 2023.
Okay. And how about you, Dominique?
5 years ago, I would have said 20 years. And now I'm saying way before 2030.
Okay.
Because things are changing so fast and the push is so huge that no one now is willing to stop the progress.
Okay. Well, listen, I'm afraid that's all the time we have today. Thank you all so much to our panelists, Dominic Collin, Terry Obrechts, Greg Bowles, and Neil Clowley, for a fantastic discussion. We hope that you all have enjoyed it too. The next webinar from Aerospace Tech Review is going to be on Wednesday, May 19th, covering the topic Digitized Maintenance, the journey from planning to execution. Further details can be found on your screen, and you can register at www.aerospace-tech-review.com. Also to remind you that the Aerospace Tech Week is going to be taking place November 3rd and 4th in Toulouse, France. And registration is now open at that same aerospace-tech-week.com website address. We have a great conference lineup with more than 120 speakers. across 6 conference tracks and 150 exhibiting companies in Europe's largest aerospace technology exhibition. So please join us in Toulouse, where we can get back to the business and networking. Thank you to the Aerospace media team, including Adrian Broadbent, Simon Barker, and Neil Walker for organizing today's events. Most importantly, thanks to all of you for joining us in this important discussion at such a crucial moment for advanced urban air mobility and the aerospace sector. Again, for info on future webinars, please visit aerospace-tech-review.com, then click on the webinars in the top left. I'm Jeff Gazzetti. Stay safe. See you soon.
Bye, everyone.